So typically we would start with a system architecture design. So that would be a high level. It would identify, okay, we'll have these components over here functioning as sensors to detect temperature and humidity, and they'll be feeding into a microcontroller of some sort. As part of the system architecture, we would typically identify the major system components. So if there is a processor or a microcontroller, we would select what that would be, again, based on what the need of the system is. If I'm designing an alarm clock or something like that, processor doesn't need to be particularly capable or powerful. It's doing a few very rudimentary, simple tasks, and that's not that big of a deal. But if I'm designing a media server that's going to go into a commercial aircraft, then has a lot more requirements built around it. And so that's going to have a much more capable and much more powerful processor in it. Identifying what those key components are, depending on what the product is and what its primary function is. If it has motors because it has to drive something, that would be part of that initial system architecture is identifying, okay, how big are the motors? What's the power source? Is it battery powered? Was it wall powered or something like that? Just all that would be part of that system architecture, which would typically be done first. Then from that would flow the hardware and embedded software design. So the hardware design is generally the first thing to be done because most of the time you can't really meaningfully write firmware until you have a hardware platform. And we'll start on the hardware design for the products pretty much immediately after we have the system architecture outlined. And the circuits will be designed in the design software. The circuit board layout will be done, and we'll produce a handful of prototypes of the first iteration of the board so that we can start doing software and firmware development on it. And when when we talk about embedded software design, that the design parts of that are a lot of things that I talked about earlier. Just how do you break down the software needs in a logical way? How do you organize it in a way that makes sense? And one of the biggest challenges that we encounter is changing requirements or scope creep. So it's fairly straightforward to develop a good design from known requirements, but it is also very common for us over the course of the design process to have clients who realize either because they just didn't know before or because they discover something that they thought was going to work a particular way, but now it doesn't, or something like that. It's very common for us to have changing requirements or scope creep, and that can impact the software design. Most of the time, it does. Now, obviously, small things we hopefully will have minimal, if any, impact on it. But if somebody initially said, "Oh, we don't need this thing to be connected to the cloud," but then halfway through development said, "You know what? We changed our mind. We want to add a radio and connect it to the cloud." That's a major difference and it heavily impacts the design. What we try to do is anticipate what we think might come down the pike and allow for or design in a way that is easier to expand or add things onto. There's limits to how much of that we can do while still being efficient in developing what it is that we need to. But that's all part of that design process is trying to not only design what we know we need, but try to anticipate at least some of what we think we might need and make sure that we haven't designed that out, that we haven't excluded that from the design, and that in just in case it does come up later on.